This is panel wiring diagram software, and this is the job it is built for. Not the ladder logic. The physical wiring of a real control panel. DIN rail terminal blocks, a PLC with its input and output cards, 24 volts of control power, and the field devices bolted to the machine. Every wire has to land somewhere exact. Let me show you how a panel drawing comes together, then draw one live. First, the thing everyone confuses. Ladder logic is the program. It lives inside the PLC as rungs, contacts, and coils, and it decides what should happen. If start and not stopped, then run the motor. That is software. A panel wiring diagram is the opposite half of the story. It is the hardware, where the copper actually goes, which terminal the sensor lands on, which output card drives which contactor, how the 24-volt supply feeds the whole rack. You need both, and they're different drawings. The ladder tells the PLC what to think. The panel diagram tells the electrician what to wire. Get the logic perfect and miswire the panel, and nothing moves. So this video is about the second drawing, the tray drawing, the one the panel builder works from, and the one the maintenance electrician traces at 2 in the morning when a line is down. One note before we go deeper. Everything I draw here is in a free browser editor. No install, no sign up. It is at CircuitDiagramMaker.app, and the link is in the description. Open it and draw along. So what is actually inside a control panel? 6 things, over and over. At the top, the main breaker, incoming power, and the disconnect that makes the panel safe to open. Below it, a power supply that steps mains down to 24 volts DC. Almost all modern control wiring runs on that 24 volts. It is safe to handle, and it is what the PLC and the sensors expect. Then the PLC itself, and this is the key part. It has 2 kinds of cards. Input cards, which listen to the field, and output cards, which drive the field. Around the PLC sit the terminal blocks, clipped onto DIN rail. Every field wire coming into the panel lands on a terminal first, never straight onto the PLC. And the muscle, contactors and relays, which take a small output signal and switch a big motor or heater. Out on the machine are the field devices. Sensors and switches feed the inputs. Actuators, valves, and lamps hang off the outputs. That is the whole panel, top to bottom. Now the part that trips everyone up, wiring the PLC inputs. An input is just the PLC asking a yes or no question. Is this sensor on? But there are 2 ways to wire it, and they are mirror images. Sourcing inputs expect the field device to supply the positive 24 volts into the input. Syncing inputs expect it to supply the 0-volt side instead. You will also hear this as PNP versus NPN. That is the sensor side of the same coin. A PNP sensor sources current. An NPN sensor syncs it. Match the sensor to the card, or the input simply never turns on, even though everything looks connected. Outputs are gentler. A PLC output card just closes a switch. It sends 24 volts to a contactor coil or a lamp, and that load does the heavy lifting. Small signal in the panel, big power out on the machine. Here is what separates a shop drawing from a sketch. Numbering. Every wire in a real panel gets a number printed on a little sleeve called a ferrule and slid onto the conductor. Every terminal gets a number too. So a wire is not the blue one. It is wire 204 landing on terminal 31. Why bother? Because color runs out fast, and a panel can hold hundreds of conductors. With numbers, anyone can trace a circuit from the drawing to the copper without guessing. The diagram and the enclosure use the exact same labels. Good panel wiring diagram software lets you put those numbers right on the wires and terminals as you draw. That is the difference between a picture and a document a builder can follow. Enough theory. Let us look at real ones. This is a PLC wiring diagram, open straight in the editor. You can see the input side and the output side laid out, terminals down the middle, field devices on the edges. Everything we just talked about on one page. And here is a fuller control panel drawing. Breaker, supply, the DIN rail, the lot. Notice how tidy it stays. The wires route in clean right angles, so you can actually follow a conductor across the sheet. Now, let's draw a small one from scratch. Blank canvas. I search the symbol library and tap parts onto the grid. A breaker for the incoming feed, a supply, a switch standing in for a field input, a block for the PLC, an output device, and a ground. These come from the free do-it-yourself pack, the one the guest editor gives you. The dedicated industrial symbols, real terminal strips, and I/O cards live on the paid tier. But the shapes here are enough to lay out the idea. Then the wires. Press W, click one pin, click the next, and the wire snaps in with square corners. Move apart, and every wire follows it. The drawing never turns into spaghetti. And here is something a plain drawing tool cannot do. Simulate it. I will open a ready-made control template, a direct online motor starter, the hardwired cousin of everything we have been drawing. There is a real spice engine inside the page. Hit Simulate, choose the DC operating point, and run it. Live voltages and currents land right on the wires. 24 volts across the control supply. Real current through the coil. If a connection were wrong, the numbers would tell you before a single wire got crimped. That is a wiring check no paper drawing can give you. When the drawing is done, it has to leave the screen. One click opens the export menu. PNG is free, good enough to drop into a work order or a group chat with a panel builder. Vector formats, PDF and SVG and DXF, sit on the paid plans. That is the honest business model, and I will say it plainly, this tool is ours. So here is the fair positioning. For clean schematic and panel drawings you can share and mark up, it is genuinely good and free to start. For a full seat licensed panel design suite with manufacturer part libraries, it is not trying to be that. One last thing, because we drew the panel, not the program. If you want to build and run the ladder logic itself, scan by scan, that is a different tool. Our sister PLC simulator does exactly that, and it is linked in the description. Draw the panel here. Execute the logic there. So that is the tray drawing, start to finish. A panel wiring diagram is the hardware side, breaker, 24-volt supply, PLC inputs and outputs, terminals, contactors, and the field devices. Wire the I/O the right way round. Number every conductor, and the panel builds itself. Open the free editor, drop in a breaker and a terminal, and wire your first input. It is at CircuitDiagramMaker.app. No install, no card. Subscribe for a new wiring video every week. See you in the next one.